Okay, it's 5.4, which is quadratic solving. Wait a minute, didn't we already do quadratics before? Didn't we do those yesterday? Can't you just use the quadratic formula to solve everything? You can solve it, but can you use the quadratic formula when you've got an inequality? No, you can't. What does the quadratic formula give you? X equals things. Those are x-intercepts, and there's actually 4 names for them. X-intercepts and zeros and solutions and roots. Good. X-intercepts, zeros, solutions, roots. That's what you get, and that's like where it touches, which is right here in this case, right? Is that a special one? Yes, because there's only one solution, and therefore that one solution is, anytime there's only one solution, that solution is the what? The vertex. Okay, if it had 2 solutions, like let's say it went through this, it has 2 solutions, then those 2 solutions don't have to be anything special. They don't have to be the vertex. They can be positives, they can be negatives. And what if it has no solutions? It's like that, doesn't touch. There's no real solutions, but there would be what? Imaginaries. How many imaginaries? 2. Imaginaries always come in sets of 2. You will never, ever, ever have only one imaginary solution. Why? Because the imaginary solutions are in the quadratic formula. And the quadratic formula always has a plus and a minus, right? And then, how come sometimes there is one solution? Because it's plus and minus what? 0. If you add and subtract 0, you'll get the same thing. That's the only case where you will get one solution. All right. Okay, so I just wanted to review a little bit of what you learned yesterday. This one is a good problem. I wish I could move that graph down, but I can't because it's kind of stuck to the other thing. So I would like you to just read through the top part in this section, okay? I don't like it when people read to me, so why don't you read it yourself? I'll pause for a second. Okay, so what are we trying to do? We're taking 2 functions and what? Somebody just summarize it for me. What are we doing with the 2 functions? They're what? We are going to graph them eventually, yes. What else? Yeah, where one's more and less than the other. Okay, good. Everybody graph for me where 2x minus 1. And just to clarify, this is f of x is like y, right? So is g of x. It's like y. So these are actually 2 equations, y equals 2x minus 1 and y equals 5. Those are very simple equations. Would you please use 2 different colors as you graph them? I don't expect these to be perfect. You don't even have, you know, tick marks on there to keep you straight. So just rough sketch is good enough. (2x minus 1). That hits this spot -1 and has a slope of 2. There we go. And then y equals 5. I'm going to use a different color for that. Let's say it's like this. Y equals 5 going like this. I'm going to extend this other one out a little further because it is going to be important later. There, something like that. Now, where are they equal to each other? What's the solution? Where they cross. That's easy. Could I have done that by some other way besides graphing them? Yes. In fact, from this graph, is it easy to tell exactly where they touch? No, it's not. So I think it'd be probably good to know that I could say 2x minus 1 and 5 are my 2 equations, and I set them what? Equal, and that's just an equation. Super easy. So add 1 to both sides, 2x equals 6, x equals 3. Cool. Does that make sense? Okay, so x equals 3. Is that the answer, the complete answer? No, it's x equals 3 and y equals what? 5, because see, y has to be 5. It says it right there. And if you didn't know that, you could always take the x equals 3 part and put it in right there, and you'll have 2 times 3 and then minus 1, which would be 6 minus 1, which is 5. Either way, you'll get 5. 3 comma 5 is my answer. That is the place where they are equal. All right? Now, could I solve the next part by graphing? Yep. F of x, is that the red one? Or is f of x the blue one? F of x is the blue one. So the question is, where's the blue one less than, I should use this sign. There we go. Less than the red one. What does less than mean in the context of a graph? Use a different word than less than. Below. Less than means below. This is important. So therefore, what's greater than mean? Above. Let me show you a couple pictures real quick. Say you have a quadratic, looks like this. Say you have another line going like this. Do you get where the blue one is below the green one? The blue one was below the green one in this little zone right here. Okay? And how would I say my answers? I would find these spots where they are equal. Like, let's say it's -1 to, let's say, 7. Okay, it's because this spot here is at -1 and the spot here is at 7. And I would say that the one function is below the other function between -1 and 7. So the answers for these are ranges. Like, I shouldn't say ranges, they're like more like domains because they're on the x, but they are a range of numbers. They're a range of values. They're a set of answers. All of this thing in here, all of these are places where the blue one is lower than or less than the green one. Where they're equal is only these two spots. And where is the other one bigger? In this little zone right here and here is where that function is larger than the green function. The blue one's greater than the green one. All right, back to this picture. So where is f of x, the blue one, less than the red one? It's in this little zone right here. Now, don't make the mistake of thinking it's like shaded in like this whole thing. No. Only the spots that are on that line work. Only the spots on this line work, but the spots below it work, but these spots above it, up here, they don't work. Okay? How about the spots where it actually touches? Where they cross, does that count? Does that work or not? No, because it says less than. It doesn't say or equal to. If it said or equal to, then you'd include the spot where they touch. All right, so how do I say that with math? Like, I have a picture now of the answer. Would you please write the answer as an interval? That kind of a thing. Would you please compare it with the kid sitting next to you? Rows 1 and 2, rows 3 and 4, rows 5 and 6, and you 2. Pause for a second. Okay, so you should have said from -infinity until it hits 3, not the 5, the 3. Remember, these are always x values when we do intervals like that. Raise your hand if you had that right. Okay, good. Then that was where it was less than. Of course, where is it greater than? Well, it's pretty easy. From what to what? From 3 to infinity. Now, I hope that these aren't super hard, but I get that for a lot of people, they're not super intuitive, that the answer would just be 2 numbers. Because it seems like the answer should be like 8 million points. And it is. It's just that all we care about in saying them is the x values. Okay? These are points. That is a point that has an x and a y. This is a point that has an x and a y. That's a point that has an x and a y. But we aren't talking about this. What we're saying, the x values are as an answer. Okay? And those x values are where the y values, remember, this is y, where the y value of this is bigger than the y value of that. But we say that from this x to this x. Okay? All right, let's move on. Now, this is just a reminder of how if it says less than, then you go below. And if it says greater than that function, then you go above that. All right? So, read this carefully. Just to clarify, they couldn't do color because it has a black and white picture originally. We added some color later, but I'll draw this in green. That's f of x. The black one, the dark black one, is g of x. Would you please answer, where is f of x equal to g of x? Be careful. Be careful how you say that. And then, where is f of x less than g of x? And where is f of x greater than g of x? I'd like you to go ahead and color them in with red and with yellow and put in stars, but I want the actual answers How would you answer it? Because it's easy to color it in. How do you actually answer these three? Give it your best shot, and then I'll tell you the answer in a sec. Okay, we're back. And I think we're just going to go with points for this, as Mr. Ping over there said, -1, 2, and 1, 2. Although I can see the argument one of the students made, which was that the answer is better to say x equals -1 and at x equals, wait a minute, +1. There we go. I can see that argument. And I could also see the argument that it's where y equals 2 that these are the same. But I think by saying it this way, aren't we saying both of these things together? So I think it's best, and I think most people chose points. We'll go with points for where f of x is equal to g of x. All right, in coloring this part in red, we said that f of x is less than g of x. F of x is the green one. That's where the green one is lower than the black one. Raise your hand if you had that. Okay, good. And then the color with yellow, I don't have a yellow marker. I'm going to go with a blue. And f of x has to be greater than or equal to g of x. Anyone have a bone to pick with my answer? Several people. Miss T. Okay, that's a problem. You're right. I wanted where f of x was greater than g of x, and I've given the answer in terms of g of x. All right. There. Anybody have a bone to pick with my answer now? Ooh, I still have 3 people, 4 people, 5, 6, 7 people. There must be something wrong, don't you think? 7 people have a bone to pick with this. Look close. What am I doing wrong? Yes, sir. From the great people of Denmark. So I should include this spot, you're saying? Why is that so important? All right, and the equal to in that sign is very important. Okay, good. Now, how do I say it? Like the answers should be said in here. How do I say it? How do I write it? Who's got what they think would be the right way to write it? Golfer? One bracket. What do the brackets signify? It touches, it works at that point. Okay, good. Any questions? All right. I'm going to pause for a moment as we move on to the next item. Okay, so we need to move on, and we have one more. This is a slide of just some practice problems. I hope that these absolute value ones would be fairly easy for you. Just remember it's like y equals on both sides. Y equals absolute value of x minus 1. That means like a v-shape move to the right. Makes sense? And then y equals, or it's greater than or equal to eventually, 3. Here's y equals 3. It's a line like that. And where is the answer? It's where the v-shape is above the 3. Where's the v-shape above the 3? Right there and right there. So now it's about the x's. So it's like from there to there, that's at what and that's at what? Well, if we actually had graph paper, we'd know exactly just by looking, okay? But I don't have graph paper, so I'm going to solve this, as they say, analytically. And I'll figure out what these two numbers are. Where exactly did they touch? Where are those x's? Okay? So I'm going to do that with an equation, and this is really important that you get this part. This is like the meat of it. Okay? This is the typical R3 kind of question you'd have to answer. This gets split into 2 equations. Did you know that it would be x minus 1 is greater than or equal to 3? Does that make sense to you as one of the equations? All you do is remove the absolute values. What I wrote here is exactly what was written, except without the absolute values. Then, and this is important that you not just try to, like, I don't know, come up with the equations in any old way. copy this equation exactly again. Exactly. X minus 1 is greater than or equal to 3. But you know that that would just be crazy to you do the exact same equation again. So you make one change to it. And instead of saying greater than or equal to 3, come on, somebody pull us out. Yes? Yes. Less than or equal to negative 3. Do you remember if we make something its opposite, like by timesing by negative 1? Do you remember when you multiply or divide by a negative, those signs have to flip? If you didn't know it now. When we change to the opposite number, we have to change to the opposite sign. Now I can solve these two little equations. The first one here, I'm going to add 1 to both sides. X is greater than or equal to 3 plus 1 is 4. And this one, I'm going to add 1 to both sides. X is less than or equal to negative 3 plus 1, which makes negative 2. There and there. I think I just found my two question marks. Do you get what I'm saying? They're at negative 2 and positive 4. And then I want it to be bigger than 4. Does that make sense? If this is 4, I want it to be bigger than that, to the right of that. And less than or equal to negative 2, that means less than as in to the left of the negative 2. If this spot right here is negative 2. Okay. If I put that all on a number line, it makes me feel like I get kind of like a complete final answer if I put it on a number line. No, you're not required to. But I think it's a good idea to see how it all goes together. Here's negative 2, here's 4, and it's bigger than or equal to 4, and it's less than or equal to negative 2. There we go. Could I write that with intervals now? Now that I have a number line for it, easy. Negative infinity to negative 2. Union with what? 4 to infinity. Okay, good. Now, the whole theme here is you can solve it with algebra. Don't even need a graph. Or you can solve it by looking at the graph. Now, you might say, well, I'm just going to always do the algebra because I like that better. But what if they give you a picture? What if they give you a picture kind of like that one? And they say, where is f of x less than g of x? You got to be able to do both. Okay? Yes, sir? True, but could you for this one? Okay, I guess you actually could on this one. Fine. What if you can't write the equations? Then you got to know how to do it from the picture and be able to say, okay, I can see this one's lower than this one, and therefore that's where my answers must be. Okay, so you got to be able to handle both. All right, now that's tennis ball lab review, which we already talked about. Let's get to this part. Actually, this slide right here. I'm not big on reading through these types of things, but this one actually has steps that are really important, and I want you to understand. For doing quadratics, which is like this kind, there is a system for doing something called sign diagrams. Okay? A sign diagram. All right. First, you rewrite it if necessary so that it has a 0 on one side. The one way I would say that is you take your quadratic and you solve it for 0. Do you get if you have this? You don't solve your quadratics when they're like that, usually. Okay, usually you solve your quadratics when they're set equal to 0. Why? Because you can't even use the quadratic formula until it's set equal to 0. Know what I'm talking about? Quadratic formula doesn't even work till it's set equal to 0. Okay, so usually we solve them for 0. That is the first step. Then find the zeros. What's the easiest way to solve a quadratic? If it'll play nice, you do what to it? You factor it. Good. If you can factor it, you should. Remember? If you can't factor it, then you can get the zeros with the quadratic formula. All right, next thing. Choose a real number in each of the intervals, and you test it. I'll show you this process in just a second. But you've got this number line here, and let's say you figured out that this is an important spot. Like last time, it was negative 2 and positive 4 are the important spots. What you do is you take a number from here, a number from here, and a number from here, and you test those numbers and see if they work or not. All right. So, looking at this, what was the first thing that we were supposed to do? Set it equal to 0. So everybody do that, please. And I know you could move this to the right side. Not a good idea. You want your equation on the left side, and then you want your sign, and then you want your 0. So get this stuff over here. Okay, so you'll have 2x squared plus x minus 3 is less than or equal to 0. Okay. Now, if I can factor it, I should. You can. So you should. Everybody take a second and factor that. And answer a question. Okay, I'll pause a second. Okay, so hopefully you've got this thing factored, and it says 2x and an x, and then it's got to be a 3 and a 1. From here, it's just guess and check until you find it. If you're way off at the beginning, then switch the numbers around. If you get the opposite of what you wanted, switch the signs around. Did you get it, sir? What is it? Can anybody verify that that is correct? Quite a few people are nodding, so it's good. Now we have x equals 1 as one of my my important spots, my roots, my zeros, my solutions, my x-intercepts. And x plus, or sorry, I got to solve this one. 2x plus 3 equals 0. 2x equals negative 3. X equals negative 3 halves. So that's one of my roots. That's one of my roots. And now I'm going to do this on a normal number line. For me, normal number lines work better than the XY chart for this. Okay? So here's x equals 1. Here's x equals negative 3 halves, also known as negative 1 1/2. At those spots, do you get that those are zeros? They will make the equation equal 0. Is that what the equation wants to be? Yes, so those spots work. They are zeros. They will make it equal 0. So this spot works and that spot works. Now, to make what's called a sign diagram, I've heard them called sign charts before. What you do is you figure out if this thing is going to work if I put in a number from this zone, like what's a number that's on that side of the 1? A 2. I stick in a 2 and I see if it works. I put a 2 there and a 2 there. I'd like you to test that quick in your head. 2 times 2 squared, is that less than or equal to 3 minus 2? What do you say? All right, doesn't work. You're right. So it's not a true statement. So this area does not work. Actually, I shouldn't squeal it like that. It almost looks like I'm shading it in. I'm going to exit like that. Doesn't work. Next, you test something like 0. Somebody put in a 0 quick. Does it work? 0 less than or equal to 3. Yes, works in there. This area works. And at the end, the other end of your sign chart, it doesn't work. You put in a negative 2, it won't work. Okay, so what's the moral of the story? I've got my answer right there as long as I can write that in interval notation. Do you get that the answer is between negative 3 halves and 1 with brackets on each end? Okay, cool. Notice I don't need any y action because these don't have any y's in them. These equations just have x's in them, don't they? So we don't have to worry about that other dimension. All right, your assignment for tonight is to try the following questions. 1 and 6, we're going to skip number 3. 1 and 6. On this page, we're only doing number 21. On this page, I do want you to try all of these. And I have to leave you with a reminder that the keys are posted. The answers for these are going to be inequality type things like this sort of deal. I'm not saying that's the right answer for number 39, but do you get if I'm within 4 units that has an absolute value kind of to it? Because you could be either positive or negative from that. Okay, so I don't have time to teach you all of this right now, I apologize, but I want you to learn from what we have, all the resources we have online for you, okay? How to do these 4. If you're not perfect, I will understand, but you can learn it. It's not hard to learn. Take you a look at one or 2 examples, you have it done, okay? So I want you to do those 4 questions. I know there's one more on the page after that. You can skip that one. That's all I have for you for today. I hope you enjoy your Halloween weekend.